how as SPCT that you can benefit from it. I mean, what advantage can be taken from your side. And third is how you can actually help the society or the industries in this case can benefit from it. So basically trying to see that how all three stakeholders can benefit. So the topic we will discuss is about what are the opportunities with the digital twin. So what is this digital twin? How it is relevant, and how as academia you can look at it for industry consulting as well as research, and help actually with the current scenario, help the current industries who are there with this kind of consulting and research. So you can have these questions on the chat window, so we can try to answer the questions as far as possible. So the whole idea is digitalization is changing everything. Everything has already changed. There are a lot of things there. The way we buy things, the way we travel, the how you communicate with each other. Whatever we are doing today, probably maybe a few years before, not so practical difficulties. The bandwidth and communication, location, a lot of things which used to come, but now what was never thought of, or not so practical, has become day-to-day activity. And as you can see, there are a lot of technologies which are disrupting. So most of you have heard of the terminology of Industry 4.0, IIoT, 3D printing, VR and AR. So a lot of technologies which are there. Some of these are listed here, which are primarily causing a change of the business models. For example, the AR and VR is trying to change the whole way that how the service is approached, how you are going to teach the people, how the machine learning becoming extremely important on each and every activities of it. So the way the future jobs, the kind of people, what people do, those things are getting completely changed. And the shop floor, we expect to have more cyber physical systems, more robotics, IoTs and sensors, and a lot of things which are there. Now, how is this, how we can leverage this, and what is that we can do? So there is a big gap from the industry as well, because a lot of things have been done traditionally, and this is a big opportunity for institutions like you, where if you are able to lead on this technology, you can actually help others as well as help ourselves. So as a broad picture, we look at digital enterprise, where the first area is ideation. So ideation is how do we create a digital twin of the product? So how accurately we are able to represent it, how you can mimic the behavior. Either it is an autonomous vehicle or a mechatronics product, or whatever be the even a new recipe mango drink that you would like to do. So it can be anything. How you create this digital twin of the product. And second is, not product alone is not sufficient, because there are a lot of products which are there which have been conceptually exceptional but never become a commercial success. So it is essential that it has to be taken through the production. So we call it as a digital twin of production. So how do you create the product into the shop floor? So what are all the operations which are required, the sequence of operations, what tools and fixtures will be required, what kind of an automation. So every activity of the shop floor, how do you create? And that is, we call it as the digital twin of production. And from the virtual world, we go into the real world, where whatever is designed, whatever is planned, how do we take it into the shop floor? So exactly to the particular operator or the machine, how you provide this information, either it is a PLC, SCADA, whatever you have as automation system, or the people who will be performing these activities, how do you communicate it? How do you ensure that whatever is planned and validated is going into the shop floor? And the last one is, we call it as a digital twin of the performance, where we have the real product which is there into the use at, it may be a machine in the shop floor, or it may be a product that we have a mobile phone and we want to use it. So it can be anything. How we are able to bring those information back into the product and production, so that there is a continuous improvement inside it. Now, the next aspect of it, when you look at how the factory of future is going to be. Now, if you see on the scale, on the x-axis, you see the automation and autonomy. So where primarily, it was in the early centuries, how you manufacture this product, which was more fixed and completely manual kind of activity. And if you put it across, we travel through the x-axis. So what you're able to do is we are able to do very well with the mass production. So we are doing very well with the mass production, where there is a lot of products we are able to produce, but it is all specific, and this automation we are able to do that. And on the other side, where there are a lot of manual operations, where there is a high amount of flexibility, and when you're looking at what the future is, there is more amount of flexibility, as well as there is autonomous in nature, which means if you look at the station there, now the right product comes there with the equipment. The equipment here in this case, it may be the AGV, and the AGV brings the product which needs to go into the particular vehicle, which is configured for a specific customer. So you see that there is a huge amount of change which has happened from the way how we have been doing the factories, which was there earlier, and what is driving today. Now, this essentially, these factories have a lot of machine-to-machine communication. You have the advanced robotics, or mobile robots, hybrid manufacturing, which means a lot of components which can get printed, and work instructions, which means every vehicle is in this example of a vehicle, can be anything. How it needs to be produced, the technology comes from AR and the logistics. So a lot of things which are there into it. And let us see that, that's at a more, higher level, 30,000 feet level picture. But when you go down into the details, then let us look at each of these specific factory of future opportunities that we can see. First, we can look at how do you create a plant? How do you create a digital representation of a plant? So you have tools to create every aspect of it. So there is a mimic of what is happening on the shop floor. And it can also go down and deeper. So not just the static representation, but you can create or simulate, say in this case, a press shop. So a press shop, the complete press line behavior, how the parts are going to be, how you're going to change the dies, how you're going to transfer the parts from one die to the next die, what will be the cycle time, what will be the setup changes which may be required. So every aspect of it. So in this case of a press, it can be for painting as well. So now you look at it, the same parts which are pressed together, welded, which we will see in the next few slides. But how you can simulate the painting scenarios, because painting is more complex. That you have a paint change in the assembly line. You can see that one car can be yellow color, next can be white, and another can be red, and so on and so forth. But in a paint, you cannot do that level of flexibility. So there is certain amount of constraints which are there. You can do that, but then it becomes more, you have to spend more time, the cost is higher, and things like that. So how do you optimize that? And how do you create programs for that? So in this case, so you have the robots which can paint. So how do you program for these robots? So which are, if you're going to do that manually, it's going to be extremely cumbersome. Manually programming the robot is also more complex in nature, because there is not much of trial and error you can do, because it takes a lot of time and it is very expensive. And importantly, the launch of the product is also going to be critical, to meet within a specific timeline. Now, there also another question which comes across, which basically says that, okay, now this is for a new line or a new plant, but what happens if there is already plant is running? So then what I can do? Now you can actually do a simple scan. The scan can be even with your photograph, your mobile cameras, or even with the laser scans, or similar capability. Now what you're able to do is able to put these pictures, and these pictures comes in as a point cloud, and you're able to actually have a hybrid scenario of this point cloud and the new changes which are there. So practically what it means is, say you have a factory, near, say there is a Hyundai factory which is there, or it can be a lot of suppliers of Hyundai who are there. Now you can actually take pictures of these, or scan some of this area, and you can actually bring it down as a digital twin of a point cloud, and then make changes, which means now in this case there is a scan which you are seeing, as well as there is the robots and some of the components which are there. That is the change which is coming into the current shop floor. So you have a hybrid of the current real world scenario and the change what you would like to do, and you're able to create that validation digitally. Now, the scenario can also be with the welding. So how you can have these automation done. So how many automations are required, or in this case, the robots, how do you distribute, if in this case, there is a weld spot, how do you plan for this? So a lot of things which can be done, and you have software digitally to do each and every aspect of it. Okay. And this can be validated, and you can actually send the offline programs into the machine so that the machine works perfectly well. Now, the same scenario, you can also optimize the running of this plant for energy consumption, the setup changes. If you're studying OR, now you see that there is, as a supplier, say for example, I'm supplying to 5 different OEMs, like maybe Hyundai, Maruti, Daimler, and so on. Now I have one line which supplies everything to everyone. Now there are number of projects or orders which are there. How do you manage the setup changes? How you can promise that you can deliver within certain time? And there is always a complexity. You cannot build the inventory, because that becomes a cost. You cannot delay, because then you will not get the further order. So a lot of problems are there. And for every supplier, every MSME, this is a big problem, because if they produce it earlier, then they lock the money. If they don't do it, then they are not going to win the business. So how do you optimize it? And this is a challenge for everyone. And there's a digital twin where you can use this to validate, optimize all this scenario. And not only the production, you can also simulate the production logistics. You can also look at the warehouse and warehouse logistics, because a lot of the e-commerce business comes inside. Now, how many warehouses are required, where it is going to be there, what kind of automation, because the number of articles which going to be there inside the warehouse is going to be extremely high. So you need huge level of automation, and it needs to bring that within the specific cycle time. It needs to approach sequence of picking. So there is a lot of simulation and optimization which goes inside. So how do you plan? How do you deliver it? Okay, and there is always new AGVs which are there, because we'd like to reduce people movement around, and rather than having 10-15 people providing the material. Now you can have a few AGVs which is there continuously running around and providing the material to the operators at the right time. So it makes work a lot more easier, as well as you also follow the social distancing, and that's something which we will see a little more in detail. You can also look at the machining side of it, and what is getting more popular, a lot of additive side of it. You must be reading it very often. There are multiple ways of doing it. So you can also see on the right hand side, right bottom, where you're also using the robot to print it. You can also have the hybrid, which is on the lower left hand side, which basically is the printing as well as machining. So manufacturers like Deckel Maho, they are able to print as well as machine on the same machine, which gives a huge level of flexibility if you're making a die, or if you're making a single type of components. For example, one specific nozzle, fuel nozzle for power generation, which one of our Siemens division which used to take several months. Now they're able to do that in few weeks, and they actually, if you don't have that spare part, or if the spare part needs to be made, then the power generation has to shut down till the time you get this part done. Now that becomes a huge advantage, when you're able to use this technology to, put to use in those kind of scenarios as well. And there are other applications like, the typical machine tinting and machining, a lot of soft machinings which are there, being popular with robotics, gives a high level of flexibility, which means like, you have a robot and, you're able to use it for multiple, if you are having a machine, now you have a turning machine and a milling machine, and it becomes a lot more, those generic machines itself becoming more specific. Now, robots becoming a lot more, generic in nature and able to program for multiple level of activities. What you can also do is for a shop floor, you can there is obviously not just the individual robots, but if you look at the complete automation, then you need to have the PLC programs working together to ensure that the shop floor is working smoothly. So how do you ensure you create the PLC program and you can validate the PLC program also without going into the shop floor? So you can have, what you're seeing here is the virtual commissioning, where you actually have the PLC program, and this PLC program is actually running not the real factory, but the virtual factory. So in effect, what you're doing is you are 100% validating your programs, ensuring that each and every signal and the safety scenarios and any other possibilities are virtually validated. Now you're looking at, say, close the door, open the door, emergency switch. If somebody puts in a hand, what happens? Every scenario, you're able to respond to that digitally with the real PLC program to do this. Now, you can also simulate for a lot of organizations. Energy is a huge cost of running the plant. Now, you can actually simulate the plant and identify how much is the energy consumption, and also look at optimization to see that what are all the possibilities, what way if they can operate this plant, you can actually reduce the energy, which actually becomes a huge saving, not only in terms of money, but also in terms of the emissions which goes into the environment. And there are a lot of new kinds of robots which are becoming more popular. So, you have cooperative robots. We will see the cobots also, but cooperative robots where you have two robots which are working together cooperatively. Now, if you look at it, basically working as two hands, and the one hand is able to send signals and put this information that how the other hand is going to work, and able to work or do much more complex operations than what possibly we used to do with a single robot. So this cooperative robots becoming more popular, and cobots also getting more popular because of the safety. So you can you don't have to have these typical safety fence and things like that, where it can understand that it is working in a human environment, and if there is anything, there's a person comes near, is able to stop and ensure that the work is a lot more smoother, and it you can bring in and take in as and when it is required. Now you can also put all this environment with the people inside. We call it as a jack. So how do you ensure the operator safety? So what level he's bending and placing this wheel into the bike. Now, is that the right posture? What is there any assistance need to be given? So if he's going to do that 20 times in an hour, then what is the impact for his safety and health? So can be simulated, and options can be evaluated that what can be done. Now, we also talked about the AR, so becoming extremely popular. So now what you're able to do is, because the number of changes and new products are increasing. Now, if you look at this operator, he gets a help step-by-step guide. Now you have this part. Now, what is the next operation, that which part he needs to pick, where he needs to place? Everything is guided step-by-step. So it can be for assembly, or it may be for a service. So assume that there is a machinery which is needs to be serviced, and you don't have a specialized operator. Now you can use the normal person who knows the machine. He can actually get the help from remotely or from the augmented reality, where the scenario is superimposed to know that exactly what are the steps which needs to be performed. So you're able to do that, and it really helps save huge amount of time and cost. For example, there's a gearbox problem in a windmill, say somewhere near Kanyakumari, and the expert is sitting in Chennai. Now you can actually switch on the AR and get this. You can also see the operator is doing, and it also provide help to what actually he needs to do through that AR. And also for additional help, there is also command and control center what needs to be done. And it can also be for high level of supply chain simulation. So supply chain simulation is a huge subject. So what kind of planning, how you can evaluate, how you can validate, all this can be done, and connect with the IoT. So you have the capability of connecting with all the sensors and pushing into the cloud. We call this as MindSphere, and you can bring this information back into the digital twin. So there is a continuous level of improvement of the shop floor data with the with this digital twin. So that's a basic background of what I would like to show on the digital twin. Now let me come more detail on this example of social distancing simulation to ramp up the production. So when you look at social distancing simulation, so let me open up the model. Okay, Bahid, can you check if you're able to see my screen?
Yeah, sir, it is visible.
Okay. So now if you look at, there is a plant which is there, and now this plant is actually, let me start producing this plant. You can actually virtually run this plant for production. So now I'm running with the operators here. As you can see the model, I'm running with 5 operators, and what is the scenario, what is the total throughput, you can actually simulate it and validate it. Now for this plant in a shift, this line, this produces about 474 components. You can also see the level of individual machine utilization which is there, and what you can also see is Now let me come down and see for the new scenarios. So this is the scenario before the COVID. Okay. Now with the current scenario, with now you need to practice the social distancing, and then so there is as a change. And now what I'm trying to do is, if I'm going to run this plant with 2 operators, then how do I run this? So how do I run this means how do I balance what activities will each other person do, and how much will be the output, what will be the shift pattern that I need to give it to the operators. Maybe is it a normal shift because people cannot go to the canteen or lunch break at the same time. So how do you give a staggered shift? So all these kind of scenarios, you can see that. Now you can also see that with these 2 operators, can you see the brown, area which is there? So you can actually see that there is a brown area. So each person actually put a distancing, saying, both person cannot come near this 1.5 meter. So you can put it as 1.5 meter or 2 meter or 1.25 meter. As you would like to do that. But while working on it now, you see that there is an area where there is a violation. And you can see that there is certain number of violations which are there with 2 operators. We'll also figure out what can be done with this. Okay. Now for this area, now I identified that there is a violation, and you want to ensure that there is some change which needs to be done, and also the amount of throughput that what you can see, those can be seen, whether that is enough, whether you want to have certain different kind of approach. You can see a lot of what if scenarios. Now in this model, what I've done is everything remains the same, except that at this level there is a small conveyor which is added. So if you're able to see that, there's a small conveyor which I have added. Now I can run back the same kind of simulation. You can also speed up depending on what you'd like to do. So I just add. Now you see there is, as long as the part starts producing, I still don't have any amount of violation. You can also see that there is the violation is nil, and the 2 people are able to work without coming, both of them coming near, in this kind of production. So at least you are able to see that, how you can balance what needs to be done. Now imagine the scenario where there is you're ramping up, and you need to produce more because the demand has increased. Now you see that with the 5 operators, now you can see the amount of brown spots which are there. Now the brown spots which are there gives you the amount of distance violations. If you're seeing there, currently it's clicking 1,500, 1,600. So there is huge amount of distance violation, which means there are a lot of operators who are coming close to each other, picking up these parts or performing some work. So there is a lot of possibilities or a risk of risk of catching if there is any issue. So you see that the total throughput is so much, but then there is a huge amount of distance violation. Now what you can do is, but I still need to produce so much, and I don't have much option to change the layout of scenario. What can be done? Anything to do a rebalance? So can I change my work so that can I minimize the distance violation? So that's a possibility you can try and do. So I try to do that. And now you can see that while there will be still some violation, but the amount of violations possibly is far lesser compared to what it was. So there was earlier about more than 2,000. Now the distance violation has somewhere stopped at nearly 1,100. So while there is certain amount of reduction, but then there is still a issue which is there. Now we can also look at what are the other possibilities, can I still meet my production target and meet the social distancing norm as well. So in this case, what I've done is add a bit of a short conveyor at 2 or 3 places, and then try to simulate the scenario where I would like to produce this, and while meeting the production requirements, but not really violating any social distancing norms. Now you can see this scenario while all the operator started working in. Now, as of now, you can see that there's no distance violation, and you're able to meet the throughput, the overall production count scenario for working. So basically, you can evaluate multiple options to do it and ensure that you are able, and you can see that there is some amount of increase in throughput as well with the additional automation which is there. You can also rebalance the work. You can also look at, say, if you also look at it here, let me show in detail. So I see that these are the 5 operators who are there and how these people are loaded. You can see that the highest one is loaded about 55%, and there is a certain amount of 20% he is spends walking, and rest 20% he is free. And you can see the 5th worker where he is actually free about 60%. So you can also look at the possibilities, what can be done, what options are there to evaluate and optimize the scenario. Now this is a specific area, how you are following this. Now what you can also do is, let me bring across, let's say, you can simulate the complete factory also. So the factory is not limited to one specific area or one particular line, but you would like to simulate from the time that the operators or the employees come inside the gate, how they follow the distance, how they go into the canteen, how they doing their logging in that time, as well as taking a lunch break or a tea break, and how they are operating each and every area. So this whole thing, actually, you can actually run it across as a complete plant. And what you're able to do is, now you can ensure that how are you ramping up, how are you working with the number of people when the production increases, how are you able to manage the scenario. Every aspect of it you'll be able to simulate it, and you can actually run through different levels of optimization, and the plants can run much more productive, much more efficient, and can service not just the current production, but also can take more opportunities. Maybe some opportunities come from the outside the countries as well. There is a possibility that what can be taken, whether they can deliver it or not. Then it is important that before they take the order, ensure that you are able to see that we are able to do the production, so that after taking the order, you're not missing it out, with not able to supply or not able to do such a thing. So all these things can be validated with a digital twin. So that's portion what I would like to show you. And with the uncertain scenarios, how you're looking at, say, when the companies are looking at it, they want to start the business with health and safety, minimizing the workforce with fluctuating demand, right? And also, how do you ensure that we have the supply chain readiness? And that is one way of starting the business. And on the operation side, how do you work with minimal people? How do you rebalance this work? How do you plan your shift? How do you maximize the productivity? And that is when the digital twin, whatever you saw, becomes extremely useful, because otherwise it becomes, you have to do it, try it on the shop floor, and then it becomes too risky, because you don't want to have multiple people coming near, and then becomes a higher problem. So in short, this digital twin of production, what you can have is, you can use it for improving the throughput and productivity, optimizing the manpower, and also reduce the inventory and the lead times, energy costs. So a lot of things you can do for with the digital twin of production. And good thing is, this is available to you, available for every student, and you can download it. You can download it now. You can just search for Technomatics plant simulation and look for the download. You can do that. So you can create a digital twin of the production, and you can take you can help the companies who are there nearby, maybe bigger and smaller companies, how they can operate, how they can optimize, and that can be a good industry project, and it can also help the companies and also benefit them in addition to actually getting the industry projects. Now the second side of it is, you can also look at the student editions for various other things like Solid Edge and pads and a lot of other things which are there from the CAE software. You can also have the digital twin, what we call as the last AIM-SIM. So this gives more about the digital twin of the product. And human, what we saw earlier, so that is, we call it as a Jack, that is also available. And there is also plant simulation, which we saw. So this is the module which we saw today, which also you can try download and use it. There's also another, a lot of interest area, because most of the students are comfortable with programming. So there is also a low-code platform, which actually, which means even people who are not expert in doing the program can actually do this and very quickly create apps. So say, for example, you want to create apps for the local industry. So you can actually use this one. We call it as a Mentix. To create apps, and what you can do with these apps, which can deploy on the cloud as well as on-premise, depending on and for creating apps, it is free. So you can start doing that, and you can also combine with the AI algorithms. So you have the Google AI or the Microsoft and AIs which are there. So you can actually use the machine learning algorithms, and you can combine it to create the apps and deploy it, possibly like in weeks, or even in days actually. And this could be a huge advantage, because you are able to create an app and you can deploy it. You can also do a lot of things internally to practice within the organization. Maybe you're doing attendance sheet, or you're creating an app for the people who are there, remotely working. So a lot of applications you can think of and create these apps, and combined with the the AI ML kind of algorithms as well. So that's basically what I would like to share on the digital twin, the whole idea with the product production and the performance side of it. And I would like to open for